I'd like to say thank you to John. John Galivan is CEO, CTO of Bridgepoint Technologies. Bridgepoint has very graciously sponsored tonight's event, so I'd like to be introduced. So thank you, John. And so I'd like to introduce John. If you'd like to say a little bit about Bridgepoint.
Yes,
we can get on with the presentation.
Yep.
Thank you, John.
Thank you, Dave. So quick plug for our company. Bridgepoint is a full-service IT firm. We do consulting. We do Xamarin work, SharePoint, custom .NET development. We also do managed services where we can be the network guys for small companies. We have a full help desk in staff where anybody who needs a printer fixed or something to be fixed remotely, they would call into our help desk and get that worked out. We also do full staffing, so we're always hiring. We're always looking for good people. At any given point in time, we probably have about 15 to 20 different open positions for some of our clients. If you go to mybridgepoint.com/careers, you'll see all of our open positions over there. So let's get on with it. So what are we talking about? We're talking about iBeacons. So just to get a feel for what I'm working with in the room. Anybody who among you here has not developed with Xamarin at all? Okay, so meaning not iBeacons, but just Xamarin in general. Hasn't used Xamarin. Okay, so I'm just gonna do maybe like a 20-second introduction of Xamarin or 30 seconds. So everybody's used Xamarin, almost. So the 20-second introduction is Xamarin is a technology that was based on the Mono framework, where it will allow you to use C# in order to compile native binaries that will run on Linux devices, which are your iPhones and your Androids. So based on that premise, the guys from Xamarin developed Mono enough so that it will work for iPhones and Androids. And throughout the years, they've improved it and made it line for it. So in a nutshell, you use C# and you produce native binaries. You're not producing applications that run on top of a web server. You're producing applications that run right alongside something that was built with Objective-C or with Eclipse and Java. And what we're going to be talking about here right now is iBeacons. So I want to set the pace here. So we're going to talk about primarily three things. I'm going to introduce what iBeacon is. Then I'm going to show you a quick demo, and then I'm going to show you a little bit of code. I would rather do the demo first rather than the code, because once we get into the code, I think we're all going to get lost in questions and other things. So the first thing is, what are iBeacons? So these are the iBeacons. These are devices. Actually, I'm going to distribute to you guys. We can pass them around. This is something that Max Notice and Three guys distributed. Those beacons are from a company called Estimo. There's one over there that's actually part of the demo. This other beacon that I distributed over there is something from, got the name, I have it listed over there. And this one is small USB 3. I have it plugged into an Apple charger, but this one is from Radius Networks. So there's a lot of companies that are selling iBeacon devices. And there's a really good reason why, because once you know what it can do, there's a lot of applications that you can do with it. So these are not iBeacons, it's not iBeacon. All right, so what is iBeacon? iBeacon is an Apple trademark. I'm showing you these devices, but they are not iBeacons. iBeacon is the word for the trademark that Apple has filed for low-powered Bluetooth LE devices to transmit information that your phones can receive. So it's a class of low-powered, low-cost transmitters that can notify nearby iOS devices of their presence. This is the Apple definition of it. So notice it says iOS 7 device. Of course, Apple will say that. But Android actually supports the same thing. Windows, I can't say the same thing for that, because they currently do not support it. And I'll talk a little bit about it later. But if you think about it, these are Bluetooth devices that emit signals. So any kind of device that has a Bluetooth receiver could conceivably listen for it. And when you listen for it, the only thing that needs to be done by the OS is to, when you hear a signal, transmit it somehow down to an API level where a developer can get to it and do things with it. So the technology enables a smartphone or other device to perform actions when it's in close proximity to a beacon. So you have your iPhone, you come close to an iBeacon, an event fires. And it's up to you to do what you want to do with the event. Where's the other items? The two white ones actually is what I need for the event. So we can leave that there. I can show you a little bit of a practical application for it. Alright, so what does iBeacon broadcast? It broadcasts four things. It broadcasts the UUID, which is a GUID. So when you turn an iBeacon on, it sends out these pulses. Like I don't know how many times every millisecond or every second, but it broadcasts it enough. Then it broadcasts these different things. The UUID is actually a GUID. Then it also broadcasts a major. Then it broadcasts a minor. And the RSSI is just like a strength of how strong is the signal from the beacon to that you're receiving. So if I have if this thing has iBeacon receivers and the iBeacon is over there, the RSSI is going to be a little bit smaller. The closer I get, it's going to be bigger. But while I'm in Bluetooth proximity, I will see it, and it'll be giving me the UUID, the major, and the minor. Now, you can buy them from 3 companies that I know about. Proximity is the one with the white iBeacons that I showed you. These are just 3 companies, but there's way more than 3. When you buy it, I believe Eskimo will give you, Eskimo Radius Networks will give you the ability to specify the UUID. And that's important, and I'll go into that later when I show you the code. Proximity is another one that they have their own UUID, and there's a reason for that too. But when you buy these things, these are like $20 to $30 a piece. Go to Radius Networks. When you say I want an iBeacon that's customized, what they mean by customized is they'll ask you for what UUID you want, essentially what GUID you want, and the majors and the minors. So you can say I want GUID blah blah blah, major 1 to 20, minor 1 to 10. So that's 200 devices, major 1 to 20, and then 10 devices for each major and minor. So that's how you actually identify each iBeacon that's broadcasting. So I'm going to do a little bit of a demo of what iBeacon can do. So I'm going to bring up this this Mac over here. I just created this little app. So what this app does is I called it the exhibitor app. Where is that called? So I have 3 beacons. Each one of the beacons will represent a car. As I come closer to one of the beacons, what you'll see is that the app will change what it's showing to represent what the car is showing. So imagine if this was like a car show. You would be you would be carrying your iPhone or your Android. You come close to a car with the app, and then you'll see information about the car in your phone as you come close. You don't have to click it or anything. All right, so I created the app. If I say start listening, what it'll do is it'll start listening for the iBeacon. So the iBeacon that this is showing is this guy right here. That's the small USB. So I made it so that the UUID of that USB or the major and minor correspond to a record in my database that points me to this Lamborghini. So now I've come closer to another one over here. You know what they say about Lamborghini? There we go. So it changed it to a Ferrari, because now I'm closer to the other one. So now I've come close to the third one. You notice it's not really lightning fast. It's probably my logic. But you get the idea of what it does. But what it's actually doing is it's receiving the iBeacons, and all 3 of those iBeacons are fighting for like just every second or so. It's transmitting. All 3 of them are transmitting. So I have to have the logic to see which one is the closest Like which one I should be showing. It looks like this one isn't going. There you go. And turn it over. So I turned it into Porsche. And I just made the simple app that'll bring up a web page, a YouTube web page, based on what was closest to what iBeacon is closest. So let's show you what that code looks like. Battery's not happy. Alright. So I wrote this code in Xamarin Forms. I'm wondering if I should show you the different version, the different solution first. Oh yeah, you know what? I'll get to the code of the demo a little bit. So I'm going to show you. So before I go into the code, let me explain to you the things that you can do with code. So you can do region monitoring. What region monitoring is if you have an iBeacon here and you are downstairs, you can turn region monitoring on, and the moment that the beacon is in proximity, it'll trigger an event. So it's just going to tell you if it's here or not. So the way this would work is you would use region monitoring to say, is a beacon around? And that will allow you to do that. Ranging is a little bit more finer. So and it actually eats up a lot more battery. Region monitoring does cycles a little bit less. Ranging does cycles a lot more, so it's going to eat up a lot of battery. So when you are close to an iBeacon, like we are in this particular room, if I turn on ranging, it's actually going to transmit the UUIDs and the signal strength and the distance. Whereas region monitoring is just, am I here, or are you nearby, or can you see me? So then the other thing you can do is broadcast. Broadcasting is something that's limited to iOS and Macs. So you cannot broadcast from an Android, as far as I know. I'd love to be proven wrong because I'd love to be able to do that from an Android. And the third thing is Windows does not support iBeacons at all. The problem with it is Windows has an OS level issue. It's not really an issue, but you could call it a feature. But the Windows OS will not pass down the Bluetooth LE signals unless you pair it. So unless you pair a Bluetooth device, you will not get any kind of information out of that Bluetooth device downstream from a Windows OS. So hopefully they would change that sometime in the Windows 9 or Windows Phone 9 or something, maybe hopefully sooner. But that's the state of it right now. I mean, I'd love for somebody to be able to hack that. I have no idea. Hopefully this year. So preview in the fall. So hopefully it'll come. There's the one thing that's really nice about this though is Apple already supported it. They actually initiated it. So this is not going to be a repeat of NFC, where everybody is expecting and hoping that Apple will support it. Apple already supports this, so it's a matter of everybody just following suit. And, you know what's going to happen. It's just a matter of when. So yeah, let's explain region monitoring. That's when something is around. Ranging accepts broadcast from the beacons. It gives you those four things, and broadcasting. So code sample. So let me show you the native implementation. So is anybody here not familiar with Xamarin Forms? So Xamarin Forms is Xamarin will allow you to use C# to produce an iOS binary or an Android binary. But there's still different projects. You have to use your own techniques to make sure that your code is being reused by both projects. So some people use MVVM Cross, some people build their own stuff. And it's not a magic out of the box. You just write one set of code and it works. You have to still take into account that you're working on an iOS environment and an Android environment. And it's your C# skills that will enable you to make sure that you are reusing your code up to the fullest. Xamarin Forms allows you to kind of have your cake and eat it too, where you would do all of your code, almost all of your code in Xamarin Forms, and then the framework will take care of bringing it down to your iOS project and your Android project. But there's a lot of disclaimers to that statement, but from from a general sense, that statement is pretty much true. And I'll show you a little bit on how that is. What I'm showing you right now is iOS project using the iBeacons without Xamarin Forms. So here's the iOS project. When you start an iOS project, it's always the app delegate. And I'm bringing up a form, which I will show over here. So iBeacons in iOS are being provided to you by the core location in the core native iOS APIs. So there's nothing else you need to install. It's all built in. And this, you can actually download the sample, a quick sample that I'm showing you here from Xamarin. This guy named Mike Bluestein made very simple examples that you could download and use. But in here, what I'm doing is I'm just doing a single iBeacon, gave it the UUID, and then I'm creating the region. But let's see it in action though. So then a little bit code is kind of not so much helpful. So here, the location manager did range because this gets called whenever something is in range. This is the thing where I told you when you are monitoring, it just shows you, am I here or not? Ranging would be, hey, I'm here and I'm this close. So this is that event. The region entered. You notice I'm not doing this from the emulator too, because you know, I haven't really tried it, but I don't think that your emulator can receive iBeacon from that. So I'm doing like an air server so that you're seeing what the iPad is seeing. So let's do F11 in there. So I'm doing all these things. Beacon region, notify, blah blah blah. So I created two buttons called Start Transmitting and Start Listening. I'm not going to go through the start transmitting because I need another iPad to do it. But suffice to say, when you hit that button, I'm going to be calling the iOS device to say start transmitting your own iBeacon signal, and so anybody who's listening could actually pick up on that. Start listening will now trigger the region entered and the did range beacons event. So we leave those there. So I'm going to press the button right here. So, let's see, I forget which one it is. Let's grab these. Oh, I hit transmitting. That's the. Alright, let's try it again. I'm going to start listening. And you see there, it actually picked up on the mid-range beacons. So if I just let it go, notice I'll keep on hitting F5 here. It just does it all the time. But if I take a look at this, let's go down to line number 113 over here. Oops. So beacons length equals 0. So it's not finding any of these beacons. Now it looks like it's not going to cooperate. But as you can see, it's very little code. You just have to implement a couple of event handlers, and whenever an iBeacon is close, it'll go into this event handler right here, and then if it finds the beacon, it'll just let you know. I kind of hope that this would work. You know what to say about live demos.
Is it? Does it have a problem with them all being the same signal strength?
So
it's possible.
they're
Yes.
conflicting.
So let's take a look at the Android version. So I want to show you the references. I got this. In order to do it for Android, you download a component from the Xamarin component store. It's free, so they're deriving off of the Radius Networks API. But just download it and use it, and then it's almost as simple as yes. Yeah, so it's a component that will you just plug it into your code. So same thing in here. There's a ranging beacons in region, and same thing with. So whenever something is in range, it'll pick the event. Maybe my Android will be a little bit more cooperative. We wanted to show you this. Alright, so let's change my unfortunately I can't show you what's going on with the Android, but hopefully we'll get it to hit the breakpoint. It'd be nice for you to see what the object looks like. Alright, so there. So zero. You know what? I think it's because my UUID is wrong. But oh good. Well, while I'm here, I want to show you this. You see that activity? Isn't that crazy? That's exactly what the Android device is doing. The reason for that is you didn't see that kind of activity in the iOS because it's built into the iOS operating system. You don't need to loop in order to get these transmissions. With Android, you're stimulating it. It's listening for these things, and you are constantly looping, and then it's sending it back to the event handler so that you can do the same exact thing. So even though Android supports it, it doesn't natively support it. You have to actually do things. In this case, the Radius Networks component is doing it for you in order for it to work. If you take a look there, it's showing you the device, a little bit too fast, RSSI, the actual. You pause it. It's actually showing the. No, I don't think I can pause it. No, that's the other thing too. Okay. Even though there's code that says you should stop listening, it just won't pass it to the API, but it's still doing it in the background. So there's something to keep in mind. With Android, even though it supports it, you got to be a little bit careful because it's going to eat up battery very quickly if you're not careful with it. So the one thing that you need to take care of when you're doing something in Android is you need to make sure that when your application goes into the background, you tell it to stop listening. Even though it's still doing it behind the scenes, it's better than nothing. As soon as it gets supported, you're gonna start seeing battery savings right there. So see, it's getting that UUID. I'm looking at a different one. All right. Well, let me show you the other one, then the Xamarin Forms. Any questions on this demo, this specific code base? Where's mine? So let's do the exhibitor application. So this is a Xamarin Forms project. Here's our portable class library at the top. This is the code that is shared. So when we talk about cross-platform development with iBeacons, this is more what we're looking at. The idea is for you to code all of your logic that handles, if I am here, I want to show the Lamborghini. If I'm there, I want to show the Porsche. So all of that code, you don't want to have to duplicate that in all of your different platforms. So although I could have done it in the other project, I wanted to use the other project as like a simpler example. But this one is not that simple, but it's not really that complicated also. So you see, this is my portable class library. This is the code that is shared between the two different platforms. Here's my Android application, and here's my iOS application. If I open up this classes, I have an iBeacon implementation for iOS and an iBeacon implementation for Android. So let me open this up. It's going to look a lot like the code that we looked at before. Resume listening, stop listening, region entered, did range beacon, so it's the same exact thing. It's doing a bunch of things that are a little bit probably too in-depth for me to go into right now. This code, by the way, this sample is available on GitHub. I'll get you the URL in the last slide. For Android, it's also the same. So I had to spend some time doing these things for Android, and it's not necessarily. I mean, this is one of the things with Xamarin. Even though people think that you just write code once and it works everywhere, you still have to do a little bit of work for certain platform-specific things like iBeacons to work and you to be able to use it from a common code base. So Xamarin Forms starts with the app.cs. I'm going to return a main form object, which is this, and setting up my handlers over there, and the entered range. Here's a little bit of the logic, and there's two different samples over here. One is the inline data, and one is the sample data. Let me switch it to the inline data first. So I'm my sample data sample there. All right.
Can I also ask a question?
Sure.
So when you design in forms, do you usually do a code in the code, or do you use it by the designer?
It's a matter of preference. Using Xamarin Forms, you have to use XAML anyway. Is there a good designer, Mike, now for Xamarin Forms? There isn't one. So if you're really into like a GUI designer, what I would do is start with an Android Android XAML file, and then just copy it over and then change what needs to be changed in order for it to work. I really wouldn't. I personally, I just hand type in and then watch it. Yeah, it is. But unfortunately, like Dave said, it is a young product. Eventually, I'm sure that'll be changed. So I'm gonna run it. This is the code for the sample app that I showed you where it's changing the cars. So I put the breakpoint on the Xamarin Forms project on the start listening click. So if you take a look here, what it's doing is I'm filling up a collection with beacons with the proximity IDs. Yeah, so this is why it's not working. I don't have that UUID a while ago. So these are the three UUIDs of the three iBeacons that I have. I'm passing it the UUID, a text ID, a major, and a minor. And you notice here I didn't pass a major and a minor on the third item. And what that does is if you don't pass a major and a minor, it'll listen for everything that matches the UUID. For Android, actually, you can omit the proximity UUID, and it'll listen for everything. So this is why you see Android apps that enumerates all of your iBeacons, but not in iOS apps. Because with iOS, they require you to pass that ID. They will not just listen blindly to everything. You need to tell it what to listen for. Being cross-platform, you always want to code for the lowest denominator. So in this case, we want to make sure that we're always passing the UUID. But let's go back into this app. So I can start listening. And start listening will add that data. And then hit F5. You see that? Let me do the breakpoint. All right, so that's what it showed. Enter range. You can take a look. It came back with one beacon. Now it came back with two. If you take a look here, you'll see each one of the beacons. If I go in there. So the unique ID is at 88. You take a look there. Can you read it? Is there a quick shortcut to make this thing bigger or clearer? No, not pop over. So it says the 8DE, which matches this. If you notice there's two, it's actually showing the two beacons with the same UUID. And in this case, it's the same thing. I'd like to show the one. There. So now showing the one. So now this is showing the 2F. So I have three beacons that are working here. These two are the 88s, and this other one is the 2F. So what if you notice, it's actually sending them back in groups. Because when you tell Apple or when you tell the iBeacon APIs to start listening for beacons, you say I want to listen for this UUID and this minor and this major. You do it one at a time. So you cannot just pass it a collection of this is what I want to listen for. You say I want to listen for it and start listening. And then you manually loop and say I want to listen for another one. So every time what you're actually doing is you're telling the system to wait for these specific beacons. So you have many handlers running all at the same time. If you can take a look here, the beacon proximity, it's a 1. This is where I do the logic, which one is the closest. So if I do this, see that change a little bit? If I do that. Let's have both of these. Whenever I test it, people in the office are looking at me funny. So I'm always moving around. So I'm trying to get it to read this other one. All right. So now, let me change it to use the actual data so that you see what the demo was built in. Any questions so far? Am I going too fast? No. Everything makes sense?
So I might be missing this, but there's no hardware support. I mean, you don't have something like right? It's only like board.
Yes, you don't have to install any kind of hardware in Android. You just need to install the software that listens by iBeacon. signals. So in this case, you just download it.
You heard of alt beacon?
Alt beacon.
Supposed to be a Android version.
So this is the native Android support. That's good. That's good that it's coming out. So it'll be nice to.
I think Radius.
Okay. So if it's something that Radius came out with, it's what this would be using. Because the Xamarin component is using Radius itself. If I do start listening here, so it immediately found that guy. So here I'm using a link query to find anything where the proximity ID is what was found in the major and the minor. And my link query actually returns a record that tells me that this is the Lamborghini. So if you go over there, then the description, and then I'm just using a web browser to point it to a YouTube video. So if let me grab this one here. This one. You notice that it, so this thing changed. And if I go into here, you'll notice that every time I put a breakpoint, it just stops there because it's running continuously. The beacon ID is different, and if I go down further in the code, the record that it found will have the Porsche. Try to do this again. So this one instead.
What's the best strategy to have a whole bunch of devices with different unit IDs, or use the major and minor?
What I would do is if you could get the same UUIDs for a specific implementation, that would be the best. Because every time you are telling it to look for a certain profile, a profile being the ID, the major, and the minor, you're telling it to, you're literally creating another event handler. So that if I hear this, I want this to run. So every time you're adding a profile search, you're adding an event handler to the code.
So the handler is per unit?
Yes. It's per combination.
Per combination.
Right. So when you tell it I want to look for I'm listening for this, it tells you when it finds something that matches that combination.
So for example, if you were to do this to do an app to automatically tell people, say, about exhibits in a museum,
Mm-hmm.
and there were 1,000 exhibits, you would need 1,000 to register 1,000 event handlers.
Yes, if they're different UUIDs. But if you have one UUID that for every single ID, and then the differences are just the majors and the minors, you would have one event handler, and every time it's going to broadcast you back.
Okay.
You wouldn't pass it the entire four.
You would only pass it the UUID, leave out the major and the minor, and we will look up anytime something with a matching UUID comes into range, it'll send it back. So then once it comes back into the event handler, you would then query, okay, what is it that I have? Is it major 1 or major 2? And that's where you would match it up with data in your database.
But I thought you said that for the Apple implementation, you had to register the major and minor.
UUID is the minimum, so you have to give it the UUID.
Well, even with, I thought you'd said that with the Apple implementation, you had to specify the major and minor in addition.
No. With Apple, you can leave out major and minor. but you have to have Ruby like.
Oh right, and with
Like,
Android,
totally, like,
you're saying you don't have to have anything.
with Android, you don't have to have anything. Okay. So you can pass it, and then it'll just send everything back that's in range. So that's pretty much it for the demo. Let's get that part of the presentation.
Now, what was the kind of lag that when you were doing the presentation, what was the kind of lag that you're getting around?
I think it has something to do with my logic. What it is see, remember, I'm receiving these events, multiple times a second, and I have to see which one is the closest. So I'm keeping track of what was my closest data in a variable. And if I get another value that's closer or equal, that's the only time I'm going to change. Since these are a little bit close to each other, I wouldn't recommend doing a system that has beacons like right here and then right here, because you're probably going to get some issues. A good distance would be maybe a meter or a couple of meters away. Although you could tweak it so that if it's a little less power, so that you can get a little bit more fine grained. It's something that you have to deal with.
I did see a demo, about 6 months ago, where they did that. They actually showed a number of iBeacons that were only a few yards away from each other. And what they did was they triangulated.
Mm-hmm.
So they weren't measuring which one's the strongest out of the box. They were able to triangulate the position of the iPhone in this case based on the relative strengths of a number of items around the room. So that's potentially a way to get around that issue. So you would basically read, say in this room, which is quite small, maybe you'd have 4 iBeacons, and by measuring the relative strength of each one, you could pretty much say within a couple of meters where you were standing.
So the technology is still a little bit crude. It'd be nice if there's somebody ingenious who would write something like that and share it. So that algorithm of determining making a quick pinpoint triangulation. Didn't have time to do anything like that for the demo, but I'm sure it's something that you guys could come up with. You get the idea. You get the event every time something is here, and you get the signal and the ID.
I would think that the actual beacon companies would make it smart enough to give you more information on which ones are close.
And they do. They give you the strength of the signal, accuracy, and in addition to the ID. So you would have to do the logic as far as how you would implement any of those.
And I think part of that is also the fact that when Apple wrote the specification, they limited the amount of information that was going to be available. So it would be pretty difficult for them to add additional information in there because they would be they wouldn't be conforming to the specification that's been written. If they did that, then they would become a unique device and a unique technology that wouldn't necessarily mix with anything else. That's not to say it won't change in the future, or maybe they come up with a way of doing that will still make it backward compatible. But I think at the moment that you're pretty much limited to the 4 bits of information that's supported.
You have a collection. Can't you just do one query of the RSSI?
Mm-hmm. That's exactly what I'm doing. Right. So I'm using Ray to match what it found. But the logical problem still is with these beacons competing with each other. The signals, some of them are stronger at times, and some of them are weaker. When I did the demo and I moved around, those beacons were far enough away for my logic to work. But if you move them a little bit closer, sometimes you would get one beacon be stronger and the other beacon be stronger. So it's for close proximity, but not that close.
Bear in mind that obviously there's going to be environmental factors as well.
Mm-hmm.
So if you had a metal partition here, for example, that's going to affect the signal. So you'll get reflection, you'll get signal blocking. So
Other Bluetooth devices?
Other Bluetooth devices that are around, so you've got to take some of those things into account, which is where maybe having, you know, a number of beacons instead of trying to do it as an absolute in terms of am I closest to this one or this one, you know, doing the triangulation type approach may compensate for that a bit better. And presumably, if you were to do it as an installation, you could actually map out, you know, you could take some around and actually map out the at least the static interference you're going to get, and maybe compensate for that a little bit as well. But I think it's about being innovative. It's about thinking about how you can use this. It's quite an exciting technology.
Yeah, I can imagine in the next few months, you know, somebody's going to come up with an algorithm that's smart enough. Given the right time, that's something that we would be working on ourselves. And when we do, we'll definitely going to be sharing it to the group. But at this time, I'm pretty sure if you search, you'll find some people who share different techniques as far as triangulating and narrowing it down. But at the core level, you know, I think it's not one of those things that I want to demo in detail how you actually triangulate any of that. It's a lot of code that you have to go through, a lot of logic to determine. The biggest challenge is to determine which one is closest. And it becomes extra challenging if you have other beacons that are sending the same kinds of signals and the same kinds of strength. So you'd have to actually do a lot of calibration for it to be effective. But on a larger scale, like a demo I showed you, if it was a car show, cars would be distanced that far enough. It would work. So, go ahead.
What does the RSSI return exactly?
It returns the signal strength in decibels of the beacon, the strength of the signal. So based on that, you could determine the accuracy, and you could also determine which one is closer, depending on the signal. So just to wrap up and summarize, you know, when you're doing Xamarin iOS, it's a native implementation. It uses core location. You have to provide the UUID. The major and the minor are optional. With Android, you can get the iBeacon service, you know, component from the Xamarin component store to use the Range Network component. The UUID is optional, and like Apple, major and minor are also optional. For Windows Phone, it's not supported. The OS doesn't entertain Bluetooth broadcasts from devices that aren't here. So no matter what you do, the OS will not send you back that signal. I've read articles of people trying to go around it, you know, to no law. Maybe somebody in this room will be able to do it and share it to everybody. That'd be nice. And the code that I showed you guys, if you wanted to try it out, you know, I put it in GitHub. We'll probably put it as a comment in the meetup so that you can download it if you want to try it out. And there's no other questions, that would be it.
So, any more questions?
Just one, was your app repair?
Oh yeah, yeah. So if you remember, with all the event handling, you have to be very, very careful about your handlers. Clean up after yourself. It eats up memory like crazy. So there's going to be a lot of testing and a lot of trial and error and a lot of nitpicking when you build something like this. Even though the concept is very easy, just keep in mind you're creating event handlers left and right, and it's polling, you know, multiple times a second. So you got to be a little bit more careful.
Yeah, I think maybe it's worth mentioning that event handlers can be a major source of memory leak when using Xamarin, and we're basically using .NET, especially if you use lambdas. So be aware, be careful, it's very important. And a lot of people forget that. A lot of people just think, oh yes, this is nice and easy, put them in, and then obviously, you know, in a non-mobile environment, it may not be that critical. In a mobile environment, it can get critical very quickly. So you just have to sort of be aware of some of those things when you're using a .NET framework.
Right. Thanks for stopping by, and I hope you guys picked up something and start writing your own iBeacon app.
Thank you, John. Thank you very much.
just wanted to say what you know, because I forgot to say at the beginning. So next month's meetup will certainly going to be on F Sharp. Bernard's, I don't know, yes, it last meetup, but I think one of the people was at that, here once at that one. Bernard entered the Xamarin's F Sharp challenge and won. So well done. And this next month's meetup will be last Thursday in the month, September, and Bernard's going to be presenting on F Sharp. Some general things about F Sharp, and then demoing F Sharp app as well, I think. So that should be quite interesting. Okay, thank you very much for coming, and see you next month.